Ian Cox, Professor of Particle Physics at Manchester University and a leader at CERN in Geneva, is with us today at the Asian Investment Conference, telling us why we should be taking a longer-term view in investing in science and in our future. Could you tell us about taking a long-term view and investing into science?
Well, I think it's, to me, self-evidently clear that investment in R&D, so the investment in new knowledge, generates wealth. In fact, I would go further. I would say that the majority of wealth in the future will come from new knowledge, new ways of using raw materials, new ideas, new pieces of electronics, things that we haven't imagined. It kind of seems obvious. An example, I think, from my institute at the University of Manchester is the discovery of graphene. Now, graphene is it's a different form of carbon. So it's not diamond and it's not graphite. It's quite strictly and literally a two-dimensional form of carbon. So you imagine little rings of carbon but in a one-atom thick layer. Very strange substance with fascinating properties. It's one of the best electrical conductors known. It's known that you can build transistors out of it, so semiconductor devices that are faster in principle than anything you can build from silicon. You can build composite materials out of it that will be stronger than virtually anything that we can build at the moment, probably the strongest material known. So you can imagine aircraft built of composites of graphene. It's one of the best conductors of heat known. It's incredible properties that are still being uncovered. So this material is potentially a multi-billion, if not multi-trillion-dollar industry. They'll revolutionize everything from structural engineering, from aircraft, all the way through to electronics.
How and when was graphene discovered?
It was discovered by Andrei Geim and Kostya Novoselov in Manchester, who were curious about things in general. They're very famous actually for being curious about things like, can you levitate live frogs in magnetic fields? So all sorts of playing around with the universe. And they discovered this new form of carbon. So the investment in that was there in the sense, it was a small investment, but it was an investment in them as scientists and in their labs at a university in order to allow them to play. And actually in his Nobel speech, Andrei Geim emphasized the value of play for discovery. So that's a message I think it's difficult to get across to government because, quite rightly, I suppose, spending taxpayers' money, government want to know what are going to be the likely returns. The answer, though, is we do not know. You never know with a specific investment in a person or a piece of research what the economic return will be.
And do you think that we can cure the economy with science?
Absolutely. I mean, the point is that our economy is based on science and it's based on engineering, and it always has been. And it's sort of obvious if you think about it. I mean, if you look at every innovation that we take for granted today, actually from the wheel, I would argue, I don't even have to start talking about mobile phones or modern electronics, the whole lot is based in some sense on an exploration of the universe, an attempt to understand it. The classic example is the transistor, which you would not be able to build without quantum theory, which was developed to understand the structure of atoms. Why? Because we were curious about the structure of atoms. So I think it's self-evidently true that our economy is based on science and engineering.
And what are some of the biggest challenges in science at the moment? You were speaking about research and development in your presentation here at the Asian Investment Conference.
I think the centre of your question is what are the challenges for us in the scientific community? How can we continue to, I suppose, convince governments, which means convincing the public actually, that an exploration of the universe is still necessary? And because if you look back in history, interestingly, this question has always been asked. It always appeared at any given time that we know enough, that we're comfortable enough, new knowledge is not necessary for our way of life. And what happens then is some revolutionary discovery is made which changes everybody's way of life, and you couldn't understand or comprehend a world without it. And examples are electricity. So Michael Faraday back in the 1820s and 1830s in London, playing around with magnets, invents the electric motor, works out how to generate electricity, transforms the modern world. Again in the 1940s, quantum theory turns into transistors. You never could imagine you would need computers. Who could have imagined in the 1940s that you would have 10, 20, 50, 100 computers in your house? And you find you wouldn't be able to live without them. So I think the lesson from history is that we have to invest. We have to convince government and the public and industry to invest in new knowledge. Otherwise, we'll stagnate and decline. That's the challenge, actually, for science. I have no doubt that there are interesting questions and wonderful things yet to be discovered that will transform everybody's lives. What I do doubt a little bit is whether, as societies, we have the ambition to continue to invest in new knowledge sufficiently, strongly, in order to generate that knowledge.
Thank you, Professor Cox. For more insights from thought leaders, check out the Asian Investment Conference website.